Hi there, my name is Dr. May, and in this video, we're going to talk about variation, both direct and inverse. Now, as I mentioned, there are two types of variation. We have variation, which is where we're going to focus most of our time, but we also have inverse or indirect variation. Now, let me explain the difference between the two before we look at a couple of examples. Direct variation means that as x increases, y also increases. So you can see it's a direct, we might use the word loosely, correlation, right? The x increases, goes up, the y goes up also. Or as x decreases, the y decreases. So a good example of this is if you work more hours, you're going to earn more money at your job. That's just one way to look at it. Now, inverse variation means that as x increases, y does the opposite. Y decreases. So, a good example of this one is if you drive more miles, you will have less gas in your tank, in your car. So, it's a way that you can relate the two variables together. As one gets bigger, in direct variation, the other gets bigger. But in inverse, as one gets bigger, the other one gets smaller. Now, both direct and inverse variation have what we call constants of variation. And if you look at the phrase constants of variation, you don't see the letter K in it. But for some reason, we let the letter K stand for the constants of variation. I'm going to show you how we use that in direct variation next. Now, I hope you're taking good notes for our direct variation here because I want you to get this good formula for the direct variation, and that is y equals kx. Remember how we said k stands for the constant of variation? So I want you to think of k here as that constant of variation. And I'm going to use two examples here to show you how we use that k. So example 2 says, if y varies directly as x, so that phrase simply means use the formula y equals kx. And y equals 6 when x is 8. Now I'm boxing that in because that is one half of the problem. Okay, so we'll have to deal with this half part first, and then we'll deal with the second part, which says find y when x is 12. Okay, so here's our first step on that first half of the problem. We're going to sub 6 for y and 8 for x. Okay, so let's see what that happens. In place of the y, I'm going to put a 6, and in place of the x, I'm going to put an 8. So could you solve for k here? Yeah, so what's happening to k? It's being multiplied by 8. So we're going to do the opposite of multiplying by 8, which is to divide by 8. Now, if you're like me, you may want to put that as a decimal. You can easily divide that in your calculator, 6 divided by 8, and you'll get 0.75. Or you could get 3/4 there. Either one works. Okay, so now that we have k, I want you to take our formula and let's put in k. Instead of y equals kx, now we're going to have y equals 0.75x. Now we're ready for the second half of the problem, which said find y when x is 12. So our final step is we're going to sub 12 for x. So that looks like y equals 0.75 times 12. And again, you can put this in your calculator and you're going to get y equals 9. And that is my final answer. But I want you to see I had to use two steps in this problem, right? The first step was from the first half of the problem. And I had to sub in for x and y to find k. And then I got to do the second half of the problem, which is when I looked and I just subbed in one value for x. Okay, let's do one more like that. A little bit more word problem like. So look at number 3 here. I've got the first sentence says the distance driven d varies directly with the time traveled t. Okay, so all that means is we're going to use our y equals kx, but instead of y and x, can you guess what letters I'm going to use? Yeah, I'm going to use D and T. So instead of Y and X, I'm going to have D equals KT. That's all that first sentence meant. Okay. Now look at the second sentence. If you have driven 175 miles for 5 hours, there's your first half of the problem. Okay. So we're going to put in 175 for D because that's a distance. And I'm going to put in 5 for T, and we'll see what we get. Okay, so let's put in 175 for D equals K times 5, right? Now, how do we get K by itself? Well, K is being multiplied by 5. So we're going to do the opposite of multiplying by 5, which is to divide by 5. And again, I hope you're going to your calculator on this one. If that division, if you need it, I get 37. Okay, that's my first half of the problem. So now I'm going to come take my formula, D equals KT, and instead of the K, I'm going to put 37. I'm ready for the last half of the problem, which the last half of the problem, sorry about my video, not sure why it's doing that. How long would you drive for 210 miles? So now I'm going to say, well, D equals 210, and let's see what we get. So I'm going to have 210 equals 37D, I'm sorry, 37T. And again, apologize about that video there. Not sure why it's doing that. And we're going to divide both sides by 37. Oh, you know what? I know why that's not working, right? Because 175 divided by 5 is not 37. It's 35. Forgive me. So my K here is 35. We're fixing all of that. So if I divide by 35, going to get my calculator out. 210 divided by 35. Yes, I still use a little old calculator because it's fast. I get 6. Okay. So my final answer here is T equals 6. But I want you to see the good part is we're doing it in 2 parts, right? And we can do the first half of the problem to find our K value. Then I want you to use that in the second half of our problem in order to solve and answer the question. All right, friends, thanks for hanging in there and watching all the way to the end of this video. If you did, be sure and comment maybe a star emoji down in the comments just to let me know you got all the way to the end. I hope this helps you. Bye, friends.